Good morning, students. So today we are going to discuss the next portion of our second unit, and in this portion we are going to study about distillation, then fractional distillation, and then crystallization. As we are doing the techniques of separation of a mixture into its components. So these three techniques we are going to discuss today. Okay. Now, first of all, where this distillation process can be used. So our topic is how can we separate a mixture of two miscible liquids. Miscible word is clear to all. It means, okay, so a miscible is clear to you. Miscible means those liquids which can be mixed very properly into each other. They are called miscible liquids. Just like water and milk, they are very much miscible. So such liquids which can mix themselves to give a homogeneous solution, they are called miscible liquids. Okay. Now let us do one activity. First of all, we are going to separate a mixture of acetone and water. Okay, these two are also very much soluble into each other and they form a single solution. Okay, now how to separate these two? So first of all, we will take this mixture in a distillation flask. What is a distillation flask and what is the apparatus used for distillation? That is in next slide, so you can see that properly. Now we are using a thermometer so that we know at what temperature a particular liquid starts boiling and it forms vapors. Okay, so thermometer is also to be used. Now we will take the given mixture in the distillation apparatus and then we will heat this mixture slowly. Okay, now acetone will form vapors first, then it will undergo condensation. That particular portion in which it undergoes condensation is called condenser. Okay, and then it is collected from the outlet of the condenser. Okay, water is having a higher boiling point than acetone, so it will be left behind in the distillation flask. Now see how it is. This is the apparatus. Here this is called distillation flask. This is distillation flask. This is Bunsen's burner, and in this we have taken the mixture. This thing is called condenser, or it was discovered by Liebig's. So it is also known as Liebig's condenser. Lebig apostrophe s. Liebig's condenser. This is to indicate the change in temperature. Now what happened when we started heating it? When we started heating the mixture, then that particular component which has a lower boiling point, that will form vapors. When it will form vapors, then vapors will rise up, and then in this particular portion those vapors will get condensed, and then that component we can collect here. Okay, the other component which is having higher boiling point, once we are not getting any liquid over here, then it means first component has gone to this side thoroughly. Okay, and then if we are able to see the change in temperature, increase in temperature, then it means now whole of the component has gone that side, or whole of the component has condensed. Okay, now this method is called distillation. Okay, now it is used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Now very important thing here is sufficient difference in their boiling points, because if there is not much difference in their boiling points, then this process cannot be used. Then we will be using another process, and that process is called fractional distillation. Okay, so now where it is used? In this there are only two things which we have to remember. Very first thing, that if I am having a mixture of two or more components and in their boiling point, difference in the boiling point is less than 25 degree, Okay, difference should be less than 25 degree. Then we have to use this process, fractional distillation process. Now in this process, what is there? There is one extra thing which is also implanted in the apparatus. That thing is called fractionating column. Okay, now fractionating column is a tube. There are so many fractionating columns. Here in this diagram, in the next slide, you will see diagram showing fractional distillation. So in this, we are using a tube which is packed with glass beads. Glass beads means very small pieces of glass. Okay, so there is a tube which is packed with glass beads, and these beads, what is their purpose? They provide surface for the vapors to cool, and they condense here itself in the fractionating column itself. They condense. Okay, so how it goes, you can see this diagram. Okay, now see here, this is called fractionating column. Okay, this is extra part as compared to distillation apparatus. Now what is the function? Okay, now see here we have taken the mixture, and there is difference in their boiling points by less than 25 degree. Okay, now what happens, you know that there are few molecules in any liquid which have higher energy values. So suppose I am having a mixture containing 100 degree and 10 degree Celsius boiling points. Okay, suppose these two are with me. Then what will happen when 100 degree Celsius temperature will reach? Then what is going to happen? Few molecules of this liquid also having higher boiling point, they will also form vapors. Why they are forming vapors? Because they are having higher energy values. Okay, so because of that they can form vapors. Now it means when vapors are forming, vapors of both the components are moving upward. Okay, now what happens, that component vapors which has higher boiling point, they undergo condensation in this portion itself, because they cannot sustain their form in gaseous state. They will be coming back in their liquid state here itself. Okay, but the other component which is having lower boiling point and that has converted into vapors, they will remain in vapor state only, and they will pass on through this, and here they will condense, and here we will collect the component. Okay, so what is the use of this fractionating column? It allows the condensation of those molecules which have come in vapor state and have higher boiling point. Okay, now how can we obtain different gases from air? Okay, now this is also one of the very important application of fractional distillation. Okay, now how we go ahead, let us discuss first the process. Air is a homogeneous mixture. Okay, and it has so many components, so many gases are there in the air, so we can separate those gases by the process of fractional distillation. Okay, now if we want oxygen gas from air, okay, then what we have to do, we have to separate all other gases present in the air. Okay, now how we do it? What we do, first of all, air is compressed by increasing the pressure and then cooled by decreasing the temperature. Okay, this is what we have done earlier. What we have done earlier, that we can compress a gas into liquid state if we increase the pressure and we decrease the temperature. So we will provide both the conditions, and then air will change into liquid form, and we will say it is liquid air. Okay, now we have got our air in the form of liquid, so all the components of air have changed in liquid state. So now there is presence of different components in different proportions. Now we will apply fractional distillation. Okay, we will keep on heating this liquid air, and then with the increase in temperature, different components will come out. Okay, so this way we can separate the different components of air by the use of fractional distillation. Now this flow chart shows the process how it goes. Okay, now first of all we took air. What we did, we compressed and cooled. Okay, how compressing and cooling is done? By increasing pressure we compress, and by decreasing temperature we cool it. Then it changes to liquid air. Okay, now what we do, now since it is liquid and there is mixture of more than two components, so what we do, now we start fractional distillation. So in this what we do, we allow to warm up slowly in fractional distillation column. Okay, then what happens, gases means those components of air, they will be in gaseous state and they will separate at different heights. Now here different heights means at different temperatures. Okay, just like oxygen will separate at this temperature minus 183 degrees Celsius, argon will separate at minus 186 degrees Celsius, nitrogen will separate at minus 196 degrees Celsius. The units are given over here. Okay, now their percentage also is known to us, so we can separate all the components of air by doing this. Okay, now let us see this diagram, that how it goes. Okay, this is the apparatus, how it is done. Now see, through filter we allow the air to get inside. Now here we apply high pressure. So when we are applying high pressure, then it will undergo compression, it will compress. Okay, now when it is compressing, then it will become hot. Now we will see this, from this side water is going down and from this side water is getting inside. Now this round pipe acts as condenser. Okay, so what it does, it brings down the temperature of hot air. Okay, hot air becomes cool over here, and then cold and compressed air is passed through this. Now here it is separator. Now we have done earlier, solid carbon dioxide is called dry ice. Solid carbon dioxide is called dry ice. So here itself, if carbon dioxide is present as one of the component in our air, here it will separate out as dry ice. Dry ice is like ice and it is white in color. Okay, and it is called ice because it looks like ice and it does not wet the surface, so it is called dry ice. So in separator, carbon dioxide will separate, then other components will be left out. Those components will undergo fractional distillation, and then we will get different components like liquid oxygen, nitrogen and argon. Okay, different heights means at different temperatures. Okay, so this is the apparatus used for this fractional distillation. Okay, now one more process. The process is crystallization. Okay, now what is crystallization and how we do it and what for it is used? Suppose we have to obtain pure copper sulfate from its impure sample. Okay, then we will do the process which is called crystallization. Now let us understand this with the help of an activity. Now take some 5 gram approx impure sample of copper sulfate in a china dish. China dish, you know, we have taken 5 gram approximately of impure sample of copper sulfate. Now we will dissolve it in minimum amount of water. Okay, then we will do the process of filtration. Okay, so that insoluble impurities can be separated. Okay, now this solution we will keep on heating it, and that process is called evaporation. Now after evaporation, till what time we have to evaporate? Till there is formation of saturated solution. Saturated solution, you know what is saturated solution? Okay, in which we cannot dissolve more solute, that is called saturated solution. So we have to take impure sample, we have to dissolve it in water, then we have to concentrate it to form saturated solution. Okay, and then we will leave that saturated solution for few hours, and we will allow it to cool, and we will not disturb it. Okay, we will keep this saturated solution at room temperature to cool slowly for few hours, it may be a day. Okay, then we will find that there is presence of, just like this is China dish and this was our solution, so we will find some solid portion over here. These solid particles, they are called crystals. So these are crystals. Okay, so these will be the crystals. Okay, so this process is called crystallization. Now how to define this? Crystallization method is used to purify solids. For example, the salt we get from seawater can have many impurities in it. To remove these impurities, the process of crystallization is used. Okay. Now what crystallization is? If we want to give the definition, then this is the definition. Crystallization is a process that separates a pure solid in the form of its crystals from the solution. Okay. Now crystallization technique is better than simple evaporation. Now see, you may think that in crystallization process we are just doing the evaporation. Okay, we are making saturated solution and then we are doing evaporation, but this is better than evaporation, simple evaporation. How it is better? These are the two reasons. First reason, some solids decompose, or some like sugar may get charred on heating to dryness. Okay, now see, charring is a process which happens in sugar. Okay, so to avoid charring process in sugar, and in case there is a solid which can decompose, to avoid those things we have to do the process of crystallization. We cannot directly evaporate it. If we will evaporate, then there may be decomposition of the substance which we are going to separate, or there may be, if it is sugar, then it may be charring of sugar may occur. Okay. Now one more thing, there may be some impurities which remain dissolved in the solution even after filtration. Okay, so on evaporation these will present as contaminates. Okay, so contamination, you know what is adulteration or contamination, one and same thing. Okay, so in order to remove those impurities, suppose there are impurities, then in crystallization process those impurities will also get removed. Okay, so crystallization is always better than this evaporation, simple evaporation. Now where do we use this crystallization? Now see, in the purification of salts we get from seawater. Seawater contains so many salts. Okay, so the most common is common salt present in seawater. So if common salt is to be separated, then we use the process of crystallization. Now separation of crystals of alum from impure sample. Fitkari, you might be knowing, it is used during shave. Okay, so that substance, if we want in pure state, then it can also be purified by the process of crystallization. Now the very much important use is, in cities drinking water is supplied from that whatever is the source, from there the process of crystallization is used, and that separates the impurities from water and makes it pure. Okay, so this is one flow chart which shows how in our homes we get pure form of water from the source. Okay, now see, reservoir means that particular place where whole of the water is present, that is called reservoir. Now from reservoir, from the source of water, it goes to first sedimentation tank. Okay, now what is sedimentation? In sedimentation, the solid portions, they get settled down. Okay, so here whatever solids are present, they will settle down in sedimentation tank itself. Okay, then there may be some suspended impurities, just like in suspension you have seen that there may be some properties, some elements, some molecules of such species which are not settling down but they are in suspended form. So in the next tank, which is called loading tank, those impurities which are in suspended form, okay, they are removed. Then it goes to filtration tank. Now in filtration tank, three things are used. Very first, coarse gravel. Coarse gravel means they are in the bigger size, okay, they are small stones, sort of thing, they are used. Then very small stones are used, gravels. Then fine sand. Sand is used. Sand is very good purifier. It allows so many suspended impurities to get stuck with it, okay. So these three things are used: very small pebbles, very small stones, then sand that is used in different layers. Water goes through these three layers, and then whatever is there in the form of impurity that gets stuck in gravels or in sand, and then water becomes free from such impurities, suspended impurities and other impurities, okay. Then it is taken in a big tank where chlorination is done. So here addition of chlorine is done, okay. It may be in the form of chlorine or bleaching powder, okay. So here bacteria is present in the water, then that gets killed, okay. Then that water is supplied to houses, okay. So this is the whole process where crystallization plays its purpose. It's okay. Now see, on the basis of whatever we have studied, you have to solve these home assignments, okay. Thank you.